due to individual charges. Okay. So, this is what we have learned so far. Now, because of this nature, suppose I take now charge Q1, Q2, Q3, Q4 and so on, and try to find what is the force on a given charge Q. Let this distance be R1, let this distance be R2, let this distance be R3, let this distance be R4. In fact, let me write them as vectors. So, this is vector, this is vector, this is vector, this is vector. Then the net force is going to be summation of individual forces on Q. And this has to be a vector sum. So, this is going to be 1 over 4 pi epsilon 0, which is common, Q1 over R1 square R1 unit vector plus Q2 over R2 square R2 unit vector plus so on. Notice that vectors have been written in such a way that whether they are positive or negative charges, all the directions are properly taken care of. So, I can write that the net force F net is equal to 1 over 4 pi epsilon 0, force is on Q, summation Qi over Ri square Ri unit vector. Sometimes this is also written as 1 over 4 pi epsilon 0 Q summation I Qi over, I can write Ri cubed and make this a vector. It is the same thing, because Ri vector divided by Ri is going to be Ri unit vector. This is also known as principle of superposition. That means the net field can be calculated by adding fields in a linear manner. What it also means is, if charge Q1 is doubled, force due to Q1 also doubled. Okay. So, now let us use this to calculate forces on some configuration. Suppose I have two charges, example 1. Suppose I have two charges separated by a certain distance, and let us say this is in the xy plane, x, y. Let this be charge q, let this be charge q, separated by a distance a. And I put a third charge q at a distance x from them. This is q. Find the force on q. Now, force, as we said earlier, on q is going to be force due to the upper charge. Let us call this 1, let us call this 2. So, this is going to be force due to 1 plus force due to 2. This is a vector force. All right. So, let us take charge 1 and see what happens. Here is charge 1 q, here is charge q, this is at a distance x, this is at a distance a by 2. The force is going to be given by this vector. So, F1 is going to be 1 over 4 pi epsilon 0 q, over 1 over 4 pi epsilon 0 q, 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 1 over 4 pi epsilon 0 What is this distance? This is x square plus a square by 4 square root. Square of that is going to be x square plus a square by 4 times unit vector in this direction. And what is this vector? This vector is nothing but this vector minus this vector. So, this is going to be x minus a by 2 y. That is a vector from charge 1 to q, charge 1 to q, and therefore, unit vector is equal to this vector x minus a by 2 y divided by its magnitude, which is going to be square root of x square plus a square by 4. So, I put this here, I am going to get that unit vector x minus a by 2 y divided by x square plus a square by 4 1/2. So, that my final answer in this case is 1 over 4 pi epsilon 0 q over x square plus a square by 4 3 by 2, which is nothing but the distance power raised to 3 times the vector x minus a by 2 y. Let me write again. I have this configuration, charge q here, charge q here, charge q here, at a distance x, a by 2, I am calling this charge 1, I am calling this charge 2, then force F1 we figured out is 1 over 4 pi epsilon 0 q over x square plus a square by 4 raised to 3 by 2 x minus a by 2 y. Let us see if it makes sense. It tells me that the force in the x direction is this way and force in the y direction is in the minus direction, which is perfectly fine because the net force is going to be like this, whose x component is like this and y component is like this. I can similarly now write F2. F2 has the same magnitude except that it's along this vector. And what is this vector? This vector is nothing but x minus a by 2 y, which is x plus a by 2 y, and therefore, F2 I can write as 1 over 4 pi epsilon 0 q over the distance cubed x square plus a square by 4 raised to 3 by 2, which is the same distance. This distance and the upper distance is the same. The vector out here changes, x plus a by 2 y. So, you now found both the forces, add them up, and I get the net force is equal to 1 over 4 pi epsilon 0 q over x square plus a square by 4 raised to 3 by 2. Notice that these parts will cancel. One is positive sign, one is negative sign. So, times 2x x. That is the answer. Note 1, if x is 0, f is equal to 0. That makes sense because if the charge is here, there is nothing really, this fellow pushes it this way, the other fellow pushes it this way, and the net force is 0. All right. 2, if x becomes very large, I can ignore a square by 4, and then the net force F is 1 over 4 pi epsilon 0 2q over x square. So, it is as if at the center there is this charge 2q sitting applying force on q. These are the certain things we are noticing due to